Let's tackle a word problem on inverse variation. When a constant force is applied to an object, the acceleration of the object varies inversely with its mass. When a certain constant force acts upon an object with mass 4 kilograms, the acceleration of the object is 11 meters per second squared. When the same force acts upon another object, its acceleration is 2 meters per second squared. What is the mass of the object? A number of things to do here. Obviously, we're going to read the problem over and over again. So don't be surprised that you read this problem, 10 times or maybe even more. The other thing you want to do is actually start introducing variables, and variables here are what? They're actually numbers, and there's going to be units of those measurements. I am going to go back to a key part of the sentence, and that key part is right here. The acceleration of the object varies inversely with its mass. I'm going to translate that first. So let's use the letter A for acceleration, and it varies inversely with its mass. We're going to use K as a proportionality constant, and inversely means put it over a denominator where the mass is present. So there is our relationship of inverse variation. The other thing you want to do here is realize what are the units of measurement. So acceleration here is actually in the units of meters per second squared. Mass here is in the units of kilograms. And so that gives you an idea of what variables you're talking about. Even if you haven't had any physics before or haven't had any science before, the idea now is look for mathematical patterns in the word problem. Let's go back and read the problem again. When a certain force acts upon an object with mass of 4 kilograms, the acceleration of the object is 11 meters per second squared. So that second sentence is actually giving you another example. So you can think of this first part here, the relationship, as the first example. Now the second example is there's actually numbers involved. So why don't I underline this? And let's just translate that. So the acceleration is 11 is now equal to what? K over the mass, which is 4. So what does this equation allow you to do? Obviously, it allows you to solve for K. So if you multiply both sides by 4, you realize K is 44. And there's your proportionality constant. The very next step is actually going to introduce another example. So there is, in some ways, each sentence is sort of providing an example. Let's figure out this. When the same force acts upon another object, its acceleration is 2 meters per second squared. So now we have 2 is equal to 44 over what? The missing variable or the missing measurement is m. And of course, if you have m in the denominator, we should always indicate that it cannot be 0. Now we need to solve for m. So why don't we multiply both sides by m, and we get 2m is now equal to what? 44, and the mass is 44 over 2, which is 22. Let's write our answer in a complete sentence. The mass of this object is 22 kilograms. I hope that helps.